So hi, I'm Matthew Wilbanks. I'm with Momentum Marketing, sales engineer with them. Started with them earlier this year and was with Untitled Power for some time prior to that. So we're going to be talking about Luxul and networking this evening. Some of the things that we're going to talk about, just go over, give you guys an idea if you're not familiar with networking or IP, what a router is, what a switch is. We're going to cover it and talk about Luxul and the different pieces that make up IP devices for a network. So some of the things we're going to briefly discuss is IP networking, what an IP address is, what makes up an IP address, different things like subnet, gateway, DNS, routers and switches, what they do and how they work and what part they make of the system. And then talk about wireless networking, because wireless now is such a huge part of the home automation platform or integration for what we do. Everything now needs an IP address. Touch on remote management, just so that we understand what you can do remotely from a customer's home and how you can manage that without having to roll a truck or send a person out to do any type of troubleshooting, internet management, and some of the advantages with Luxul. So some of the things that we know, these are some older numbers, but we've seen how important IP is to what we do in our day-to-day, what our customers, our integrators, our dealers want. Back in 2016, networking communication was relatively small, but 2017, probably leads, well, it's number one on the chart here. And we see that here in 2018. So we're going to cover some of the basics of what we have for Luxul, what makes up a network. The number one component is a router for a customer's network. The router is the kind of the traffic cop for a customer's network to the internet. That is the gatekeeper of the data that's in the customer's network to outside on the internet. Switches are devices that connect networking devices to the network. Computer, printer, access points, a thermostat, various things along those lines, hardwired Xbox, devices that are hardwired onto the network. And then access points. Access points take that data and make it wireless. They plug into switches or the router, and they create the wireless roaming of the network. So, IP addressing components. There's really four things that make an IP address for a device on the network. You've seen it, we've talked about it before with various things. Customer asks what the IP address of a device is, and you always hear like 192.168.something. Well, that is an actual address, a numeric address for a device on the network. A subnet, you hear that, and you always hear almost always the same thing over and over for a residential system of a 255.255.255.0. And you go, what is that? Well, we'll talk about that, but then the default gateway, 192.168.0.1. Default gateway, again, goes back to the router, what the router does, and it is the gateway, the traffic cop between the customer's network and the internet itself. And then finally, a DNS server, where we're pointing to look up a translation for how humans speak versus how computers speak. So we'll talk about that. But those are the four components that make up the IP address. Oh, sorry. Skipping a little too fast here. So what is the IP address? A collection of four numbers separated by a dot. 192.168.0.1, 192.168.100.1, and so on. 10.1.10.1. Different number sets that set up a location on a customer's network. What do those mean? Well, ultimately, it's like a phone number. We all have different phone numbers with area codes, different numbers that represent where that number is in relationship to where we are, where a phone number is assigned. Well, one of the things that you see here is they're all based off of a 0 to 255. It's based off of the power of 2 to the power of 8. That creates that octet, 0 to 255. So you have a total of 256 numbers that create that octet. And then we can work off of those numbers to create that IP address. One of the things that you see now is a series of 4 numbers, and that's called IP version 4. Soon, and we're starting to see it on some devices now, is IP version 6, IPv6, where that ultimately becomes 6 octets to allow for more IP addresses on a network. But for the most part, residential, like commercial, you're going to see a 192.168 or some form of that. We'll talk more about how that grows. So, touched on this briefly about how big the network is, a 192.168, 0 to 1, up to 254. There are 2 addresses that are special, .0 and .255, that you can't use for devices on that network, but anything between 1 to 254 you can. Those are reserved for special things on the network that we really don't need for what you would have in the home. And then we have our public IP addresses and our private IP addresses. The 192.168, the 172.16, and the 10 dot range are unique to local area networks. Those you'll find in the home, commercial building. Occasionally you'll see, most common is the 192.168. Occasionally you'll see an ISP router provide a 10 dot IP address for a customer's network. Very far and few between. But it's just a matter of how many IP addresses can be found on that local area network. So does it matter what IP addresses that we use for working with in the network? Yes. And that's where our DHCP comes into play. The router provides IP addresses for devices that come and go onto the network. You'll see this within setting up a router within the Luxul, that this is usually set at .100 range up to anywhere from 50 to 100 IP addresses that are offered in a pool for devices coming and going. I'll talk a little bit more about this and why we use this versus manually setting them. Manual set IP addresses are for devices that never leave a network. So if you have a customer that has an AVR or a television or a Nest thermostat, something along those, you would want to static IP address those so that they're never going to leave. They never have to be in a part of a pool that are for addresses that are for devices that come and go. So if you have a cell phone, an iPad, something along those lines, and you want to get onto a friend's network or the dealer network here at Wave, the router will assign an IP address that will be used for a certain amount of time while you're here. Once you leave, that IP address has been reserved for 12 hours, 24 hours for that, and stored till that device leaves and it's gone. And then that IP address goes back into a pool. Well, a static IP address is for a device, again, that never leaves, an AVR, a television. There's no reason for that IP address to change. So you have a select amount of IP addresses based off of how you create that IP address of a 192.168. You have up to 254 IP addresses to work with. You don't want to put devices or IP addresses into where that pool lies. So you want to separate those two. So some of the things that you have to be aware of when setting up an IP address, You have to know the range that you're working with. If it's a 192.168, depending upon that router, what you're planning for that, if it's a commercial project, if it's a 172, how many IP addresses do you need? The same subnet, the subnet that those IP addresses fall under. Again, we'll talk a little bit about that. And then first three numbers are the same, except the last digit based off of how many IP addresses. And that's determined by the subnet. So I will show you that. So as you can see here, we have the three different subnets for setting up how many IP addresses to work with. 255, 255, 2550 is a Class C network. This allows us the 254 IP addresses. So anything from 1.1 up to 1.254 is what we can work with in that range. But as you can see, it's a 192.168.1 number, where the next one is a 192.168.2. That subnet dictates of that range how many IPs of that third octet we can work with. If I switch that to 255.255.0.0, we now get 65,000 IP addresses to work with. So everything from 192.168.0.1 all the way up to 192.168.254.254 we can work with. 65,000 IP addresses. That's something that's not quite used often for residential or even for light commercial applications. 65,000 IP addresses is a very large scheme of IPs to be working with. Finally, the 255.0.0.0 IP range is 16 million plus IP addresses to work with. Something that would be used in a commercial environment, multiple locations, multiple servers, multiple devices. That's called a Class A. You will see that used with Just Add Power and how many devices they can work with on that scheme. So, default gateway is, again, the traffic cop for the LAN to the internet. Path out of the area code, typically the router. Once in a blue moon for a residential application, you will see this where it's not the router itself that you're using there. So whatever the IP address for the router is where you want to point that computer out to the internet. So typically it's a 192.168.0.1 or 1.1, something along those lines. But it is to get out of that local area network. Are you all familiar with a DNS server? All right. So a DNS server, domain name server, is a way for us to remember websites and for us to look up and point to servers on the internet. So a typical domain name server, we type a URL or a website into a browser, be it ESPN. That information goes to the global DNS server, finds it, and then sends back the actual IP address of ESPN's web server. Then our device takes that information and then sends it to ESPN, pulling their website off of their server. So what we see for their homepage of their website is now populates on the device. So a DNS server is a means for us to talk human to computers and have them where we don't have to remember all the phone numbers. We remember them by the contacts, by the names that we have in there. So this is a device that allows us to just remember the names of the websites. So just a brief understanding of how IPs they work in a local area network versus, or what we need to see for our clients, our dealers, for networking, just to give you a brief understanding, hopefully. One of the things I talk about with dealers on understanding networking is that they'll come in and they just plug things in and they hope that it works and not worry about where that IP address is or what that IP needs to be, or if it's in the DHCP pool or that range. So one of the things I always reference to dealers is to make a template of what they are doing in a project for their techs to have familiarity of those projects moving forward. One of the things I follow is setting up routers and gateways always at 0.1 or 1.1, stressing them to put things that belong on the network at a 2 through a 10 for like switches. Here, this one talks 11 to 20 for wireless access points. That's fine. Biggest thing about this is making a template for what works for them. As you can see here, the automation from 30 to 49, lighting control, none of this is set in stone. Do they have to make it this way? Absolutely not. But the biggest thing for them to do is have organization and teach those to their techs. So as they go from project to project, they can follow something and their techs understand what's going on in a project. So documentation is the key for understanding the network. All right. So routers, what does a router do? Well, briefly talked about, the router is the traffic cop from the customer's network to the internet. It bridges the information, what information needs to stay on the customer side versus going out to the internet. So the wide area network is what's outside of that customer's network. Where the customer's network is called the LAN. The WAN is everything outside of the router. The local area network, again, is the customer's network. So all those devices in there would be the switches, access points, laptops, HVAC systems, so on. Anything that resides within that customer's home. And ultimately, like I said, it bridges the two networks between there. Skip that one. So router types. We've seen the different types of routers. A wireless router has the router capability built into it, but it has an access point also built into it. Then we have the wired routers that are rack mounted, don't have any other bells and whistles in them, no access points, they are just a router. Well, when do we use which router? Well, it really depends on what we're looking for the router to do, where the router is being placed, what are we asking it to do. So if it's a small home, most of the time I recommend using just a wireless router, something that's not getting a rack or they already have a SMC panel in that house. Then you would want to use a wireless router in that location and then build off of that. Depending upon how small of a home it is, you could use something where it repeats the wireless signal. But again, that's dependent upon the size of the home and how many devices will be connecting to it. So if there's one person, two people, and they're not doing much streaming or many things are connecting to it, you could get away with just a repeater and trying to boost that signal. But once you really start to tax the network and add devices onto the network, you want to consider moving to a much larger system. A wireless router that has a controller that you can add access points into it. Or going to a wired router that's going to go into a rack that is in a closet somewhere and now putting in access points with a separate controller for a much larger project, up to 16 access points, inside, outside, and so on. It's really determined what their budget is and the size and scope of how big their home or project is for determining what size with that. But honestly, smaller homes, wireless router, add one or two access point. With the 3150 is a great device for that. But the wired routers offer more speed, higher capabilities, some even more functions that we'll talk about here in a minute. So, why do I put in a new router? And this is a huge one, especially for you guys, as far as what you should be talking to your dealers about. An additional router and not relying on an ISP's router is a must, especially for our dealers, to remove some of the hiccups that they run into, the problems that they run into. Where it says separate from ISP triple play services. Something like 5 years ago here in Texas, we've had AT&T move their UVerse boxes from the coax connection and start piggybacking the devices on the customer's network. Well, that became a massive problem with how the ISP flooded the network with the audio video across that. A simple solution to that problem was to add a router behind the ISP's router and to separate that. That audio video traffic would be removed from the rest of the customer's network. It's a very, very easy, simple fix, and also removes the blame that is put on the integrator from the customer when they run into problems like that, or when the ISP has done something to that router. So adding a second router into a customer's home is, bar none, something that must be done right away. Software capabilities, there's some great things that you can do within the router for a VPN, QoS, quality of service, VLAN, setting up a guest network for a customer's house, making sure dad's internet speed is bar none the best, or the mom, versus the kids watching Netflix. Some of the things that you can do with the Luxul router. And then horsepower. You have to have some of the higher end wired routers to achieve the gigabit speed for the homes. So the sheer power of what they can do. One of the great things about having the wired routers is the ability to add redundancy for internet and a second ISP to a home. If you have a client that is mission critical, that they always have internet capabilities, the Luxul router has, multiple WAN ports, so you can add multiple modems. So you could have a cable modem, a satellite modem, something along those lines where you have the ability to do both. And then virtual private networks. This is a great way to have an extension into the home, a secured extension into that. Much better. We should not be talking about port forwarding anymore. Port forwarding just causes massive security holes in allowing people to get into a router and get behind that firewall very conveniently. VPNs create a secured tunnel into that home. Security is the key with this, and this is a feature that's built into the Luxul routers. So briefly, this was what I was talking about here with the cascading the modems, and what I highly recommend to all the dealers when they're dealing with the ISP is to always add a second router to put their devices in behind. The data comes into that modem, and then essentially it gets assigned an IP address to the Luxul router. And as you can see here, we want to manage this so that the data coming into this is set up so that the public IP address of the ISP's router is then translated to the router. This is done through setting up a DMZ, something that you guys don't have to worry about as far as you instructing your dealers to do that, but it's something that's available in the ISP's router to set up a hole through their firewall to the Luxul router to enable that. It essentially just turns this into a modem and allows that IP address that modem would get to go to that router, so the internet sees that. Kind of bypasses the ISP's router firewall capabilities by doing that, which is necessary. So And here it talks about setting up the DMZ. Again, something that tech support with Wave can help. They do it all the time. Also, Luxul is fantastic for setting up DMZs and understanding that. So switches. What's a switch? Well, the switch transfers the data from the router to devices plugged in on the network. Just moves the data. There's a couple different types of switches, how efficiently they move data across that network. We have fast Ethernet gigabit. Fast Ethernet are going away now because of, I say that, let me rephrase. Fast Ethernet are a 10100 switch, a bit slower compared to more of the traditional gigabit switches that we see. The cost of the gigabit switches keep getting less and less, and it's working at 10 times the speed of a fast Ethernet switch. We still see them, but honestly, we shouldn't be pushing too much of those because of the fact that everything needs to be going to gigabit. Just everything is using more and more bandwidth to move that. Unmanaged switches, you're going to hear some of this, unmanaged versus managed switches. How the data moves to that switch. Unmanaged, there is no management. The data just goes to the ports, looking through a MAC lookup of the devices and sends the data to those ports. A managed switch, where we can start assigning IP addresses and VLANs and moving that data and securing that data to only certain ports, so it doesn't go across the entire system. Power over Ethernet, this allows us to power devices up across a cat wire and not have to plug the device in via a power supply or something along those lines. And then the sheer size number of ports. Switches as small as 5 ports up to 52 ports. And then 2 types of switch layers. Layer 2 basic switching versus layer 3, which would be classified under a managed switch. So which switch should I use? Well, for basic systems, dealers that come in here have a couple devices. Even when it's 10, 15, 24 devices, you can use an unmanaged switch. But it really depends on what they're trying to achieve, how many devices in their home will be streaming or connected to the network, how much data is moving through that. Not asking you guys to do calculations, but typical unmanaged switch, 24 ports, 16 ports, usually not a problem. But once a dealer starts getting into 3 switches in a network, we should be considering putting a managed switch in there to help manage where all that data is going through. It's just making their network much more efficient, especially as we see more and more devices that are streaming, HBO, Netflix, Hulu, all these different things, all these different ways of getting that data across that. It starts to become an ugly mess if we don't put any type of management in there. And it can actually slow the system down using unmanaged switches. And ultimately, that customer starts complaining to the dealer, and then so on and so forth. With managed, we can do a lot more. We can control the amount of data that the kids have, how much data is going to automation devices, voice over IP, limiting and making sure that the amount of data going to those devices is at least of a minimum amount. So we can prioritize that data going across that network. So there's a lot more that can be done with the switches, the managed switches, that allow us to control and make that network much more efficient. And then finally, PoE, power management. I'll talk a little bit more about that. So here, best practice, 3 or more 24-port switches, at least 1 managed. You never want to see us cascading switches. So how to connect to the network. Basic network, physical connection. Here we have the internet going to a router, and we have 3 ports coming out of that router and going into 3 switches into a system. This is something that we want to see the dealers, how they should be plugging network switches into each other. Whereas the large 24-port switch is going into the router, the 8-port PoE switch is also going into the router, and the little 8-port switch is going into the router. We would add latency we would add extra time if we plugged directly from the router into the 24-port switch, and then from the 24-port switch into the 8-port switch, and then, or the 8-port PoE switch, and then from the 8-port PoE switch into the 8-port switch. We would continue to add more and more time, and you would notice this on a network, and it would slow down to the point where the customer would really start to notice the difference on doing something like that. Another type of configuration that you would want to see is connecting to the router into a managed switch, and then coming off of that managed switch to your other switches into the system. So here again, just talking about how, just jumped ahead, coming off the router, going into that managed switch, that 24-port managed switch, then coming off the 8-port PoE switch, and then the other 8-port switch plugs into that managed switch. Again, just managing and controlling that data across that network. So selecting a switch really depends upon how many devices plan on going on the system. If you're going to be plugging PoE devices into it, this is more and more important as we see. More and more devices are PoE. Just add power, all our devices are PoE. Cameras, many other things going into that. One of the things too that you'll start to see here in our industry is that speakers will come out PoE. Lighting control is going to become PoE. Physical lights will have enough power. Currently there are up to 30 watts of power available through PoE. You'll start to see PoE++, and another one that I believe will go up to ultimately 82 watts of power. Speaker bars that will be powered via a Cat 5 or a Cat 6 via PoE. So just some really cool stuff that, I mean, is right on the horizon here this summer that will start shipping. So, but some cool stuff with that. So understanding how much power those devices need is how you can determine what kind of switch, how big of a switch, the power required for that. So, and something that you guys will have to look at working with the dealers of how much they need for a switch. So what is PoE power? One cable provides the power and the data. 100 meters follows the standard network topography from the device to the switch, 100 meters. Does not require a licensed electrician. It's low voltage, 48 volts. But again, it's really dependent upon how many watts it's going to that device. And then sources can be standalone, injector or switch. Access points Luxul has, everyone comes with a PoE injector in the box. But if you have a PoE switch, you don't need that injector. So it saves one more plug, much less wire and headache with that. So, and then, so some of the small form factor unmanaged switches, you guys sell a lot of these, the XGS 1024, 24-port, unmanaged gigabit switch. Then you have the little 1008, 8 ports, gigabit speed. And the XGS 1005, also 5 gigabit ports. As you can see up here, that fast Ethernet is kind of going the way of the dodo, just in the sheer amount of speed necessary, that bandwidth to move that data. So the gigabit is where we're at. And it doesn't stop with gigabit. There are switches out there, not so much for the residential market, or even like commercial, that get into 10 gigabit, 40 gigabit, 100 gigabit, and they get real expensive. But we're starting to see those come down. Typical managed gigabit switch, you're looking about $30, $40 a port. 10 gigabit switch is about $100 a port. So much more expensive to go to a 10 gigabit switch. So here with Luxul, the AV series, all the ports are in the back. Anything that starts with an A is in the AV series. Nice and clean, so all the wiring is in the rack and the customer just sees the lights on the front of it. The X series has the ports on the front of the switches. So here we're showing the 4424P, the 2616, and the 2424P PoE switches. Those are also commonly used for the Just Add Power system. Then we have their two monster switches, 52 ports of PoE, used quite often for large Just Add Power systems. There are two types. One is the 5248, 52 ports, not stackable. And then you have the 7048, where you can link them together and continue to grow a AV over IP system, or whatever you would like to. Have multiple ones, two of these into a home, where a larger home where they're hooking up AV over IP, access points, other switches, other computers, other devices going into that system. So, wireless networking. Something that becomes a bit more frustrating in our industry. Everybody wants to be wireless. And for the most part, we're getting better and better with coverage for wireless and devices on the system. But ultimately, there's still some room to grow and educate. So wireless access point ultimately just takes data, puts it across a wireless transmission, and sends that data back and forth across the system. Pretty much here, wireless access point is a standalone device that does that, whereas a wireless router ultimately has a wireless access point built into the router. Makes it a little bit simpler, smaller projects, where it's somewhat centrally located, or just a compact system. So currently we have two standards for 802.11, frequencies that we use, not standards. Single band 2.4 gigahertz, and then we have the dual band, which also sends data across the 5 gigahertz range. 2.4 goes twice the distance, but it is not as fast as 5 gigahertz, whereas 5 gigahertz is much faster, and but does not penetrate different materials as well as the 2.4 gigahertz does. So we have combination devices that are both 2.4 and 5 gigahertz. With those, one of the big things about wireless is making sure that those connections are secured. WEP was one of the first forms of security for wireless, not used much anymore. WPA, believe it or not, is still used today, but we have come up with WPA2, which is much more secure than the WPA. And then the different types of encryption, AES versus TKIP. Primarily, most devices used today, that are sold today, are using the WPA2 and the AES encryption. Just both have, over time, have become much more secure. It's what you should recommend. WEP has been hacked many, many times. Doesn't take much to hack a WEP security.
WPA3.
Oh, yeah.
It's even more secure than A2.
It's going to continue to grow. So and like I said, WPA2 AES is the highest, most common for now. WPA3 will be coming soon. So how far does it go? Pretty much the ultimate question every access point. How far does this go? Well, it really depends. What's dependent upon how far wireless transmission goes? Well, how powerful is that radio in that device? Signal strength, is there any other devices around it? By physical placement, is it in the open, or is it in a laundry room next to a metal closet next to 2 washers and 2 dryers? And then really depends on how many access points you have in the home, and then type of construction. If it's concrete and steel, if it's plaster and lath, if it is drywall or wood. All of those play into how far wireless can go. So one of the first things is the shear output of the radio. As you can see here, some devices, traditional devices, 70 to 100 milliwatts. High powered was considered 400 to 750. Luxul devices are a full 1,000 milliwatts, 1 watt of power. That is mandated by the FCC. You can't go above that unless you want to get an FCC license. But as far as access points for what the consumer can use readily, Luxul meets the maximum output. So that's one that continues to determine how far the access point can go. The signal strength, what does it mean? We've all seen this, hopefully you've seen this, on your laptop, on your iPad, of how strong your signal is for your device. And here, the lower the number, the better. As you can see here, -100, that's horrible. And quite honestly, 60 to 70, you want to be above or below 60, in the 50-40 range. That is a good signal. Once you start to get into between the 60 and 70, that becomes problematic. It's going to semi-work. Not all the time. It's going to add some more time in getting that data across there, but ultimately, you will start to notice the signal strength, or your data stop flowing. So, Wi-Fi speeds. We all see on the side of a box how fast that access point or that router can go, theoretically. Well, there's a couple things that play into that, and to understand and to educate the dealers and the customers about Wi-Fi signal. So the Wi-Fi speed on the side of a box is based off of how many radios and how fast those radios can talk and communicate all together. So with Wi-Fi, Wi-Fi is a bit different than a typical wired connection. Wired connections allow for duplex, allowing both transmit and receive at the same time. Where Wi-Fi can only transmit and has to wait, and then it can receive. So that really determines the amount of speed on a Wi-Fi. So there, half duplex, only one at a time. Speed depends on many variables: signal strength, channel utilization, other RF interference. If there's other networks around and that you can see that within the system, they will affect the speed. Number of clients on the devices. Let's say we have one access point in this room and we're all on the Wi-Fi. It's going to talk to me first and then report, then talk to your phone, then talk to your phone, talk to your phone, before it comes back and sends data back to me. It happens extremely fast, but it's still taking up time and slowing the overall system going down. That's where access points start adding more and more channels. You'll see access points with a 2x2 or a 3x3. Those are more radios that can talk to more devices at one time. That's why it's important when you're talking to dealers to tell them the difference between a 1410 versus a 1510 versus an 810, how slow an 810 will be versus a 1510, and some of the technology that's different in a 1510 versus an 810 access point. Customer education is key. Ultimately, customer signs up for gigabit from Google for their home, grabs their phone, does speed test and goes, hey, I'm only getting 300 down. Why? Well, that access point will never give you gigabit speed out. Also, the radio in your device will never be able to achieve 1 gig on the radio, the network card that's built into the device. So educating customers to how Wi-Fi works, how they can achieve those speeds to get that gigabit. That gigabit is only designed for being wired and achieving 1 gigabit in speed down from their ISP. So here, 5 gigahertz max versus real world, and what's advertised on the side of the box versus 3 radios versus 2 radios, the different types of Wi-Fi that's out there, AC versus N, and the speeds that you can get. So here, the 900N 3x3, maximum you will ever see will be 450 megabits on that internet, that Wi-Fi connection. But real world, you're probably only going to get to see 200 because it depends on where they're, how close they are to that access point. If there's other access points or other homes around them that are also on that same Wi-Fi channel, that can cause an issue and slow down what they're seeing in their home. So just to give you an idea of what is expected with Wi-Fi. So one of the new things that we're seeing more and more of is wireless roaming, and how roaming is becoming much more affordable within the residential realm. So with 1 access point, there's really no roaming. Small home, you have that ISP router or a Luxul wireless router, just the one that covers the entire house. But more and more, we're starting to see where there's an access point or a wireless router upstairs, and then maybe an access point downstairs, or another different type of configuration, maybe an access point out on the patio and 2 in the house. So now we have 3 access points. Well, roaming is an issue when we have those multiple access points. And here, the roaming becomes a problem in that the device itself sees the 1 access point and connects, and will hold on to that as long as it possibly can. Why? Because it's designed that way. This thing goes, okay, I see Wi-Fi, I'm on it. I'm going to hold on to that as long as I possibly can because I know I'm on that Wi-Fi. It doesn't go out roaming looking for other access points when this signal starts to degrade to a certain extent. Once it becomes bad enough where it's failing, then it will start to go searching for new access points. But the problem is the signal has already degraded and the customer's experience has already become a problem. Well, that's where wireless controllers come into play. And skip over here. So, wireless controllers. The XWC 1000 wireless controller. This is the first separate wireless controller for the CI dealer. This helps remove that problem of devices trying to figure out what access point they should be on and how long they should hold on to that access point. This here supports up to 16 access points. Luxul just recently came out with their new 1440 wireless access point for outdoors, and it works great with that one. So, give you an idea here, with the access point placement and the devices, it doesn't matter where this device, well, excuse me, where the access points are placed in the home, it does. You don't want to have an access point in a corner. You want to somewhat separate the home into thirds when placing access points so that it covers them. You don't have dead spots in the center here. So the wireless controller will allow this phone, as it travels through the home, to be handed off from what access point it deems necessary based off of it manages what access point is strongest for that device. Whereas this device, if it just continued to walk through here, it would wait till it got all the way to the end of this location here and then drop and then finally get picked back up. Well, if you're streaming music or something along those lines, you're going to notice that become a problem. Home automation, something you can't have because the customer is going to start complaining, well, I just lost signal with it. With the wireless controller, that would take care of that problem. That change happens within about 30 milliseconds from going access point to access point. Customer's not going to notice 30 milliseconds. So one of the great things about access point placement is that Luxul offers wireless site surveys. And if you have integrators that come in and say, hey, listen, here's a set of plans, but I'm not sure where to put these access points, what would you recommend? Well, you can take these set of plans and scan them in and send them to Luxul. Luxul has design services. They will determine with some questions, a little questionnaire to be answered of what ISP, where they're located, what their construction material is, and help design that system and for those placement of those access points within that home. That's something that's offered free for Luxul. So be aware of that. Let your dealers know that's available, especially if you have dealers that are coming new into networking or wireless networking. This is available for them. So, what happens when you put access points too close together? Not much. So they just continue, especially with the controller. The controller has the ability to manage the power of those access points to make sure it's a seamless interaction across the entire home or those access points for those devices. Where is it here? So before the wireless controller, we would recommend to integrators to, when they have multiple access points, they want to make sure that their SSIDs and the security are the same. Plus, you want to make sure that they're on the same yes, you want to make sure that they're on the same channel so that in the same home, they seamlessly move to the next access point. But it still takes more time without a controller. They will have to drop off and jump onto that next one. But that's where the wireless controller comes into play. And that's, like I said, available on the 3150, the router with the access point already built into it. You can add 2 more access points onto that system, or the standalone and add up to 16 access points based off of the needs of the size of the home. So one of the things that we always talk about is just measuring the signal strength of what's in the home. What are they actually seeing? And these are some of the free or somewhat inexpensive tools that are available for viewing what's on the network or what's in that customer's home. One that I'm somewhat fond of is the Insider, available on Win, Mac, and Android. Some of the have different integrators like other ones, but here's an example of what you can see in a system with that. I highly recommend these for you guys to talk to your integrators about. Insider is available on metageek.com, but you can see what's going on the network, various access points, what their signal strength are, if there's multiple homes, different SSIDs, what frequencies they're on, and this allows you to really see what's going on in the home. If there's problems, if there's a neighbor that has too strong of a signal strength, or one problem I came across recently for a friend was complained that he had a ring kept falling off his network and a couple other devices. Well, I went over there, opened up my MacBook and opened up Insider and saw that in the neighborhood, we could see about 8 different routers and access points in that neighborhood. And all of them were set on the same frequency on channel 6. Well, that was causing problems because the Ring doorbell was seeing the neighbor across the street, another one, and it was seeing it all in that same frequency. Well, simple thing to do was just physically change the channel from 6 to 11. After that, never had a problem since. But that tool was able to save so much time and headache of seeing what was going on in that network or in that neighborhood around them. So just something I'm very big in understanding what's going around you, the tools, using the correct tool for the job, and this is a fantastic one. This one's not, I think you can get the software for a small fee. They also have a device that goes with this that allows you to see everything from 900 megahertz up to 5 gigahertz. And so it's great for understanding if there's issues with Zigbee and Z-Wave and Wi-Fi. And that's available through them for that tool. But something to let your integrators know about, your dealers know about. Finally, measuring with mobile devices. Yes, you don't use your laptop or have integrators use them or the techs use them. These have much more powerful network cards in them and radios. Use phones, and the older, the better. They are the worst device for testing networks. And if it works on this device, then it's going to work on other devices that have a much stronger or better network card within them. So, so mobile devices can show 6 to 10 decibels lower than a laptop. So like I said, the cell phone is the worst thing for it. So if it works on this, it's going to work on everything else. So remote management, Domotz. This is a great tool that is now available within the Epic 3, Epic 5, the 3150, I believe, for managing and remote access to a customer's network. Have you guys seen this in working before or know much about Domotz? Well, Domotz, like I said, cool, very cool for remote access and seeing what's on a network and the problems with a network, or if there is a problem with a network. So let me show you here. So here's an interface for the Domotz system. Once it's connected to the network, you would create a location. It will specify that on a map and see that. It takes about 15 minutes for the device to discover all the devices that are on the network. And when it does that, it will start to show you that information. So here, so the dashboard. So this, once it's discovered those devices on the network, it shows you how many devices it's found, how many are online. It constantly tests so many times a day, tests the speed from what it's seeing from the ISP. So this one here is seeing 99 megs down and 6 megs up. Alerts, collaboration. What's fantastic about this is that the customer or the technician can give authorization to Luxul to help view the system and to help discover if there's problems in the system. Reporting log, manufacturing support. Here's the dashboard on the phone or the app, so you could see it through that. And then this also allows them, so here under the Pro side, this shows you all the lists, the devices that are discovered on that, from MAC addresses to the manufacturer of that device, when it connected last, what the IP address of that device is, if it's currently up, and what those are. So here you can see it has an ABR 5000 wireless controller and then a managed 4424 in this location. But it's also seen a Wii and an iPad and an Android device. When you click on one of the devices, it shows you even more information. So here, this is for the router. What type of router? The status change, it's currently online. We can share this with the support desk and have the ability to access that, the IP address. So much information that the technician can see or the customer can see of what's going on their network. You can set up alerts with the system so that if the router goes down or stops communicating to the Domotz cloud, it'll send a push alert to a technician or to a help desk for that company. Remote tunnel and connecting to device interface. So one of the great things about this, with a help desk or a technician has a problem, gets a call from the customer and says, listen, I can't hear anything out of my living room speakers. Technician can open their Domotz into that system, find that site, click in it, then open up and check, let's say, the Onkyo receiver, and make a tunnel into that web interface of that Onkyo receiver and see if that Onkyo receiver is, let's say, muted or the volume is turned all the way down. And they can solve that problem instantly without having to send a technician to that site. So it gives you a very, very powerful tool to going in and seeing what's going on to a system. RTI, you can tunnel into an RTI controller and see the diagnostic page through the Domotz app. So very, very cool, a great amount of information remotely through with Domotz. Detailed network communication. So this tells you what's going on at each port, how much data is moving through the port, what the port is connected at, if it's 1 gigabit, if it's 10/100, what's going on with those. And then you also have PoE power, where you can power cycle ports and control the power to those devices. So if you need to reboot a PoE, an IP camera, something along those lines, the Domotz allows you to power cycle those devices. Detailed information, how things are connected through the switch and those devices, what's going on, how much data is moving through those ports. Remote management for PDUs. You can assign PDU outlets to specific devices through Domotz. So if you see an Onkyo receiver that maybe the network card is frozen, something along those lines, you can click on that device and say power cycle it, and it will power cycle that outlet on that PDU that's connected and configured within the Domotz system. A lot of data, a lot of capabilities with what you could do with Domotz. Customize alerts if they have internet. If they have internet connection, if devices have gone down, you can set up alerts to either go to your help desk or to a technician, letting you know when it's connected, if it's gone down and reconnected, and so on, and how long it's been down for. Another beauty of Luxul products is the ability to router limits, to control the data going through that router, and to give a bit of parental control for parents in the home. So one second. So what's fantastic about this is that you can manage devices based off of MAC address, IP address, and give them a certain amount of time that they can be on the internet or what they can see to the internet, and really limit certain access to websites out there. It's fantastic for being managed by the homeowner, something that the technician doesn't have to do. That way they're not having to go back and talk to the customer, okay, what time do you want this device to do it? The customer can do it and set those limits. Very easy for the homeowners to do. And the device is running on the router, so it's built into the router itself. Here's where you can create groups and set up the controls for those devices. Where is it? Guests, kids. adding different types of limits, what you want control of. It gives you an extreme amount of detail of controlling that content coming through that router. Setting up different exceptions, times of the content, what needs to be seen at what times, limiting how much streaming to what devices at what times, setting up the Xbox gaming devices, again, what times you want them to have, what time you want them to have access to the internet, and then being able to see who's visited what at what time, what device, gives you a lot of detail through router limits, something that, again, integrators can set up for the end user, but allow the end user to manage. And then, so just some of the costs associated with it and what they can choose and see, and consumers pay router limits directly. So, all right. Some of the Luxul advantages, what makes Luxul stand out versus other companies. Exclusively sold through the CDIA channel. So you won't see Luxul on Amazon. It's not being shopped against other devices out there. Pricing's not available online. It's through you guys. Affordable, very easy compared to other devices that represent themselves as enterprise edition products. You do not have to be a certified network engineer to set up and program Luxul devices. And they include a 3-year warranty, so which is fantastic. Finally, the Luxul IP network courses you can see online. Additional courses besides this one. Other things with IP networking basic, setting up a VPN, wireless controller and roaming, fantastic. Finally, Luxul has fantastic support. Tech support, phone calls, chatting online. Luxul.com is a great resource for from everything from firmware to how-tos to different channels of seeing YouTube and so on for videos to setting up a wireless controller and so on. And that's everything. So thank you guys for Luxul.